arcs of the same length subtend angles 60 degrees and 75 degrees at the center. Find the ratio of their radii. Now, in such questions which involve informations like the radii of a circle, the length of the arc of a circle, and the angle that the arc subtends on the center, and you are given part of this information and required to find the rest, it's useful to draw a rough sketch besides keeping the formula in mind. So that's what we'll try to do here. So we have two circles, one hopefully smaller and the other one bigger, and it is given that these two circles have arcs of the same length. So let's draw that arc here. Let's say these are the two arcs which are of the same length in these two circles, and these two arcs subtend 60 degrees and 75 degrees at the center. So intuitively we should get it that if two arcs are of the same length and one subtends a bigger angle than the other, the arc that subtends bigger angle has to be in the smaller circle. So for example this one. So this arc, for example, here subtends an angle of 75 degrees, whereas this other arc which has the same, both arcs have the same length, let us say that length is L. This other arc in the other circle, it subtends an angle of 60 degrees at the center. And we know the relationship between the angle theta in radians that is subtended at the center by an arc, which is equal to the length of the arc divided by the radius of the circle. So let us label the two radii as R1 and R2. So what we have here is that 60 degrees angle, which we need to convert into radians because this formula theta equals L by R applies when theta is expressed in radians. So 60 degrees becomes 60 into pi by 180 radians, and that is equal to the length of the arc L divided by radius of the first circle, which is R1. That's our first equation. And in the second circle, the angle subtended is 75 degrees, so that becomes 75 into pi by 180 radians, which is equal to the length of the arc, which is the same as in the first case, divided by the radius R2 of the second circle. This is our second equation. And so we have these two equations which we can label as 1 and 2. And because we are required to find the ratio of the radii of the two circles, that is R1 by R2, we can simply take the ratio of these two equations, that is 2 by 1, because R1 must come in the numerator. So this is equal to simply 75 by 60, because pi and 180 both get cancelled when we take the ratio, and this is equal to 5 by 4. Therefore we can say that R1 is to R2 is equal to 5 is to 4. That's our answer. Now please note here that in each of these terms, 60 into pi by 180 and 75 into pi by 180, we could have taken pi as 3.14 or 22 by 7, and we could have multiplied it with 60 and divided by 180 here, and likewise here we could have multiplied by 70 and divided by 180. But we did not do that because we knew that we would have to take the ratio eventually of these two equations, and therefore a lot of terms would get cancelled out, for example pi as well as 180, and our calculations would become pretty simple. And in general it's a good practice when you know that eventually certain terms may get cancelled out. You don't do the calculations in the intermediate steps. Keep your terms as they are and wait for the opportunity when you can cancel out majority of them. Let us now move to our third question.